Hi, welcome to another Unity tutorial. In this tutorial, I'm going to show you how to make this radial button that when you click on it, it opens up a series of child buttons that you can use for whatever sort of interface I guess you're designing. And then when you click on it, it goes back in. So you'll see that the buttons radiate out in a circle from the center. And as they come out, they also fade in and they fade out when you click on the button again to close it. Before we begin the coding though, we need to have a look at the maths that's working in the background to make these buttons operate the way they do. So the code that I'm going to show you will allow you to add any number of buttons as child buttons to this blue button, and it will then equally spread them out around this 90 degrees of a circle here. Right, so I've drawn up this quick image to illustrate what's going on maths wise. I'm not going to go into the background or the derivation of these formulas, but these are just very handy formulas to know. I learnt these when I went to university and I have used them ever since. You never know when you want to have to draw a circle or something around the circumference of a circle in games, or whether you're doing something else with coding, but these I use them all the time, so I guess they're pretty much burned into my brain. Now this is the big button down here, and when we create these other buttons that go around it, they will be sitting on the circumference of a circle that is going to be surrounding this button, and they'll start up here, which will be like a 0 degrees position, and go down to here, which will be a 90 degrees position. Now the maths involved uses cosine for determining the x coordinate and sine for determining the y coordinate. Each of those values has to be multiplied by the radius. So that's how far away you want these buttons to be from the main button. So this button here, for example, if you were to calculate it at being 22 degrees, then its x will be cosine of 22. You'd have to convert that to radians. So radians of 22 degrees multiplied by the radius, which might be, I don't know, on 100, for example. And then any button you create, if it was at 22, even at 45 degrees, as long as it's 100 from that center, it'll all be there, and there'll be another one there and there. They'll be all equidistant from there. This one here, if you were to calculate it, let's say that its distance is 120 from the center, then it's going to be cosine of 45 degrees multiplied by 120 and sine of 45 degrees multiplied by 120, and that will give you all of these points around here. And just using these formulas, you can find the position of anything relative to the center of something else that traverses around it in a circle. Right, so now we know that, let's get on with the coding. The first thing you need is a main button, and I've created a main button here. So you would right click on the hierarchy and go UI button, and that will create a button and a canvas that it will live on, as well as give you an event system which will control all of the input. Now the only thing you really need to be concerned about is the main button. The main button will have the code attached to it, and every child of the main button will become part of its radial menu system that it has. So we will automatically code it to pick up all of the children and then display them in a circle around the main button. So for the main button here, the blue one, I've just found a circle PNG file which has been imported as a sprite into our assets. Then I created 7 children buttons that I have attached to the main button, and these are all currently set to the same icon, though you could change them to different sprites as you need them to be. There's nothing special about these buttons, so I just clicked on main button in the hierarchy, right click, UI, and then went button. And after I got one button, I just duplicated it, and the size is 32 by 32 in this case, though you can make it whatever. So the code itself, when it's calculating the position of the button, it's going to do it from the pivot point to the pivot point. So the pivot point of the main button to the pivot point of this button. So obviously you can't make the children buttons bigger in radius than the distance that's going to be between the main button and where all these appear on the screen after you have rolled them out. Right, so now that I've explained that, let's go back to our button and have a look at the code that's now on there. So this code is called Radial Menu Controller. It's a C# script. And if I open it up, we can see what's inside of here. Okay, so the first thing, just check that you have these libraries included at the top, which is a Unity Engine UI, system.collections.generic, and system.link, as well as we'll be using some different features from these. Right, the first thing inside the class is a list of buttons. So rather than using an array, we're using a list because it's a little bit more powerful what you can do with it. It's called child buttons, and we create a new list of buttons to put our buttons into, because the code has to automatically find all of the children that are attached to our main button. Now, if you wanted to drag and drop all of your children in manually to your main button, then you could just have an array, a public array, and then when it's exposed in the inspector, just drag and drop all of those child buttons across. I just found this to be a simpler solution because you can add as many buttons as you like and it will just automatically adjust itself. Next is a bool, which will keep track of whether we have opened or closed the menu that the blue button is controlling. And then finally an int, which is the button distance. So this will be from the center of the blue button to the center of any child button, how far it will be. And remember from our formula we looked at earlier that the distance is very important part of the actual calculations. Right, in the start function, we'll grab hold of all of our child buttons that we created the list for up here. And we'll use a get components in children function. Now, if you've used this before, you'll know that if the object that you're trying to get the components in children also has that component on it, such as the button in this case, then it will also pick up the parent object, not just all of the children. So because that blue button is a button, it would end up in our list of child buttons, and we don't want that. So by using this script here, thanks to our system.link library, we can actually filter out the parent object from the list. So that blue button itself, using this code here where it's saying that the parent is not the parent of the object that we've found, which would be the blue button, then we're not going to add that to list. So all of the others will be added to the list. So that's very handy to know that. Right, next is, I guess it's a kind of a cheats way to make sure that my blue button will run this open menu function that's down here without going through the inspector and setting it up manually. This code here will grab hold of the button, the blue button itself. It will add a listener to that button, which is going to be this open menu function. Now, if you've used buttons before and assigned different functions to them, you might have gone like this. So you've gone main button, and then in the inspector you go down to the on click, and it's going to be looking for a function to run. The function that's going to run is in this Radial menu controller script that we're currently writing. So it's going to look for a function that's attached to itself. So you would drag and drop it down into here, and then look in this function list down in the Radial menu controller, and then you'd go through and you would find that open menu button, which is probably slightly off of your screen at this point, but it is there. Now, if you don't want to set that manually, I'll just turn this back off again to nothing, then that little line of code is doing it for you, which is nice and handy. And then finally, we're setting the center pivot point of the large blue button to be right in its middle rather than one of its corners. So halfway in the X and halfway in the Y, which means that the circle being drawn around the blue button where the other buttons will be aligned to will come right from the center point. Now, again, you could go into the inspector and actually set the pivot point of that blue button over here to 0.5 to 0.5, which it is, but why leave it to chance, I guess, and it just will make it happen automatically for you. Right, so that's the start function. And now to the open menu function that will run when we click the blue button. First thing is that the open boolean will be set to not open. So if it's false, it will be set to not false, so it'll be set to true. Then next time you click on it, if it's true, it'll be set to not true, which will set it back to false. So this is like a switch. It's going to switch that open value back and forward between true and false for you. And next we calculate the angle that will be between each of the buttons based on how many buttons we have. Now, the total angle that we're going for is 90 degrees. So that's actually spreading the buttons out around in this 90 degrees here. And we will go for 90 degrees divided by child buttons dot count minus 1. Now, that's because you want one button starting on 0 and the other one ending on pretty much 90 degrees. So that's why you're actually calculating the gaps between them. So if you had 7 buttons, then you actually need to have 6 gaps between them because there's one at the beginning and there's one right at the end. Now, that value that calculate from the 90 degrees will be in degrees, but the sine and cosine functions like to work in radians. And if you're like me, you'll always forget to convert to radians, and then things will look really weird, and you'll spend, a good part of a couple of hours looking for what's wrong in your code. So always remember to multiply by this mathf.degrees to radians value to make sure that you're working in radians. Now, of course, you could do something here like, pi divided by 2 if you think in radians. I don't think in radians, so I always just use degrees and convert it, though it would probably be a little bit more efficient to start with radians. But that's just me. Right, next we're going to loop through all of our buttons and position them on the screen. So this for loop is going to just loop around through all the buttons in the list and position them one at a time. Now, if open is true, so that we're actually going from a closed menu state to an open menu state, that's when we need to calculate the actual position of each button based on the angle around the circle, or in this case around the quarter circle. So the xpos is calculated with the cosine of the angle multiplied by I, so multiplied by the button number. So the first button will actually be at an angle of 0. So I will be 0 multiplying it by our angle. So let's say our angle was, for easy calculations, 10. Then the first one will be at position 0. The second one would be at angle 10 multiplied by 1, which would give you 10. The next one would be at angle 10 multiplied by 2, which would give you 20, so that you get it at 0, 10, 20, 30, because you need to keep incrementing the angle as you go around by the same amount. And that's why we're multiplying by I. And then we're also multiplying by the button distance, because that's our radius that we need in there as well. Now, once we've done that, we can then use our new X and Y positions to set the actual location of the button. And that's here. Now, you'll notice we're not just setting the child button's position to xpos and ypos. We're setting it to xpos plus the position or the center of the blue button, and the same with Y, because these buttons are relative to the blue button. So if the blue button was to move somewhere else on the screen, this will still work. If you don't add the position of the blue button, then the calculations will all be happening around the origin or around 0, 0 on your screen, and that may not be where you actually want your buttons to appear. Now, finally, if close happens to be false, so that we're getting rid of our buttons, then we've got this else statement which will take each of your child buttons and just set their position back to the position of the blue button. So basically making them all zip back in and sit right in the center of that blue button. Right, so let's save this and go back to Unity and run it. All right, so if I click the blue button, you'll see that they've all appeared in a nice quarter circle around the blue button. If I click it again, they zip back into the middle. Okay, so the calculations are working really well for us. To make it so that the buttons transition nicely rather than popping in and out in a sort of an animation, we can add some simple code that will just loop through and lerp the position of the actual buttons for us. So open up the program. Now this code, instead of using open menu down here that actually snaps the buttons from one location to another, we need to keep a track of where the button needs to get to and then use that as like a goal position that the button will sort of move slowly towards. So for that, first of all, we'll need to add something to store all the button positions in, and I'll just create a vector2 array for that and call it button goal pos. Then we need to initialize our button goal pos array. I'll do that down here after we've got the number of buttons, child buttons. So button goal pos equals new vector 2 and then child buttons dot count. So now our button goal pos array will be the same size as the child buttons list to store all of our goal positions in, which we will then put into here. Instead of setting the child button position, we'll actually put it into our vector array. So I'm going to copy that goal button pos and actually set the value here. And get rid of the transform.position so that this vector2 that we're calculating will go straight into our goal position, and the same down here as well when we want to transition back. Next, we need to add a coroutine that's going to run in the background, or I should say kind of in parallel at the same time as the update loop is, so that we can slowly transition the buttons from one position to the other. So just under here, I'm going to paste in that function so that you don't have to watch me painfully type it all out. And this is it here. So it's basically move buttons, and it starts by looping through each button and setting that button's state to active, which reminds me we need to go through each button at the top and turn it all to inactive, so that when we first open the game, then the blue button is showing but all the child buttons are actually inactive. Right, next we're going to create an integer value called loops, which will keep track of the number of loops that we've gone through to move the button from where it is to its goal position. And we will then ensure that while loops is less than or equal to the button distance divided by the speed, where the speed is basically the steps that we're going to take from getting from our current button position to our goal button position. Right, so then we have a yield to cause this function to take a break and let other things run, and then it comes back to it, and then it loops through all of the buttons and actually starts moving them a little bit at a time. At the same time, it's going to grab hold of each button's color, which we do with this line here, and modify the alpha on that button so that it will fade in and it will fade out. So if open, so remember our Boolean value from before, if we are opening up, then our alpha value, which would be our color.a value, is going to go from whatever it is, which is assumably like 0 or a very low value, up to 1 at the same speed that we're moving. And then we go in the opposite direction. If we're closing, then we'll use the color of the button, which at this point will now be an alpha value of 1. And we take it down to 0, so we're actually going backwards. And every time we calculate a new alpha value for the color, you need to actually put it back in to the image color, because we've taken it out up here and putting it back in here, because Unity won't allow us to modify just the color's alpha value unless you do it like this. And next, we are setting the position of the button, which is there, using a vector2.lerp, which is going to move us from our current position towards our goal at a certain speed, which is there. So this is a similar lerp that you use for moving characters around. It's no different. So it's just going to slowly move along a line from one location to the other. And then we update our loops value here so that we can test how many times we've looped around, because after we've looped around button distance divided by speed number of times, our button will be at its final destination. Now, just after that while loop, we're doing a if not open test. We will make all of the buttons become inactive so that it makes them invisible and turns them off once they've folded back into that main blue button. Right, so now that I'm thinking about this set active, we need to grab that code there and put it up the top here in the start function to make sure that all of the buttons are actually inactive right at the beginning. So if I just go move that back, so you're looping through all the buttons and we're setting them to false. All right. Now, before we save and continue on, we have to do one last thing, which is at the bottom of our open menu. After we've calculated the position of all the buttons, so this is the new position for the buttons, we then need to start this coroutine running down here. So start coroutine right at the bottom of that open menu function. Move buttons. And that will then start this running. Okay, so save that and we'll go back. Oh, I've got an error. Speed is missing, that's right. So in our move buttons code, we've got this speed value here, which is telling us how fast everything is moving. So therefore we need to define that up the top. Float speed equals, let's make it 2f. So you can modify the speed depending on how fast you want the buttons to open and close. Okay, so we'll save that. Let's go back to Unity and let's run it. Now you'll see that the buttons became inactive, and when I click they'll become active, but they won't fade in. They're going to fade out because we have that code in there, and then there'll be 0 alpha there. And if you click it again, you'll see that they fade in. But the very first time you do it, they won't be active, and it might be too fast for you to see. But when you click on it, they will suddenly appear and then go out. So they won't fade in because that first alpha value for those buttons hasn't been set to 0. So one little change you need to make in the code, in the start function where you're setting your buttons to be inactive to begin with, just above there, I would add 2 more lines of code here. The first one, which isn't the color at all. But what it's doing is ensuring that those child buttons are right on top of the blue button itself, because you might have added them and they could be positioned all around the screen. This will just make sure that they're all aligned right in the center of that blue button. And then the next line here, we'll go through and for all of the colors, set the color of the button to full on red, green and blue channel, which is just white, and an alpha of 0. Now, by setting this to white, don't worry, your button doesn't become white. It just means that you'll be able to fully appreciate, I guess, its sprite that you've attached to it, so that there's no sort of shading on it whatsoever. It will be at its perfect colorage of that sprite, and with an alpha of 0, of course. So now, save this and press play, you will get them actually fade in, and you can see that fading in and fading out. And you can adjust how fast they do that by working on that speed. Okay, so that's all there is to a radial menu. Now this one goes from 90 degrees. You can play around with the angles if you want it to go right around or you want it to go in a different direction. It's all about figuring out, where's the starting angle, where's the final angle, how many total angles do we want. It could be like 180 degrees type of menu system. You just need to adjust your formulas to account for that. Okay, so I hope you enjoyed this tutorial and I've helped you with some of the development that you're doing, and I'll talk to you next time.